हरिः कन्ना।
So before we look into the various statistical techniques and methods that we can apply for different types of data that we have seen so far. So one thing I just want to make sure that, and one thing just I want to reiterate is the difference between a variable and a data type. So in most of the headings that you're seeing in my slides, I used as a variable, and sometimes I used as a data, like dichotomous data or dichotomous variable, ordinal data or ordinal variable, or nominal data or nominal variable. I'm interchangeably using this data and then variable, but they're not same as you think, but they can interchangeably use it. A data is the one data is nothing but it consists of a number of records, a number of points. It represents the attribute of any entity. That is what your data. Whereas in a variable is one of the attribute of that entity. So that's what the difference between a data and a variable. When I say data, when I say an ordinal data, this applies to the all the points, all the data points which are there inside that data table. When I say that ordinal variable, so we will be considering one of the attribute of that whole data records, and then so we will be specifically talking about that variable. Okay, so now I hope you got the difference between a data and then variable. So but by and large it gives a same meaning. So when we say ordinal data or ordinal variable, so it's by and large same, other than you're specifically naming the data with a variable such as height, weight, gender, feedback, happiness scale, such as you are naming that data. That's it, that's the only difference. Okay, now let's get back to the work. So the most important question that I want to ask you is, why do we bother with a taxonomy of data types? So it turns out that for the purposes of data analysis and predictive modeling, the data type is important to help determine the type of visual display, data analysis, or statistical model. So in fact, data science software such as Python or R programming language uses these data types to improve computational performance. More important, the data type for a variable determines how software will handle computations for that variable. So, software engineers and database programmers may wonder why we even need the notion of categorical and ordinal data for analytics. After all, categories are merely a collection of text or numeric values, and the underlying database automatically handles the internal representation. However, explicit identification of data as categorical, as distinct from text, does offer some advantages. What are those advantages? So that we will be looking in this section. The first advantage is knowing the data is categorical can act as a signal telling software how statistical procedures such as producing a chart or fitting a model should behave. In particular, ordinal data can be represented as an ordered factor in R. So preserving a user specified ordering in charts, tables, and models. If you take a Python, in Python programming language, scikit-learn supports ordinal data with sklearn.preprocessing.ordinal encoder. Remember this method we will be using. Remember this package. Ordinal encoder will be using this package uh, in our projects in ML algorithms. The second advantage is storage and indexing can be optimized as in a relational database. And the third one, the possible values a given categorical variable can take or enforced in the software like an enum. The third benefit that we have discussed can lead to unintended, unintended or unexpected behavior. So the default behavior of data import functions in R is to automatically convert a text column into a factor. Subsequent operations on the column will assume that the only allowable values for that column are the ones originally imported, and assigning a new text value will introduce a warning and produce an NA. NA is nothing but a missing value. So the pandas package in Python will not make such a conversion automatically. However, you can specify a column as categorical explicitly in the read underscore CSV function. So that all argument you can put it in your while you're reading your CSV file, that time only you can put as a categorical column argument in your read CSV function. So now to wrap up this section, the main thing, let's discuss the main summary points here. One, data is typically classified in software by type. Two, data types include numeric. So under numeric, we get continuous and discrete. And we have categorical. Under categorical, we have nominal, binary or dichotomous, and ordinal. The third one, data typing in software acts as a signal to the software on how to process the data. So that's the reason a typing or data type is very, very, very much important when learning this is very, very much important before you start dealing with your algorithms.